Okay, so I am here to briefly go over the basics of reading a periodic table. So I have a periodic table right here, a rough sketch of a periodic table right here. This is not what an actual periodic table would look like because you have all this blank space. This is where all your elements would go. But since there's over 100 elements, I haven't memorized them all, so I just did a rough sketch of it. But if you get any test or any periodic table, they don't expect you to know every single element. It's usually given to you on any test or any experiment you need to do or anything. So all of this would be filled in with elements. But on the top row here, you have, over here you have 1A, 2A, 3A, 4A, 5A, all those A's, those are called your main group elements, and those are basically the elements like we know their charge, we know things about them, they're our main group elements. Now we have over here in this column we have our B, our B's, and those are our transition elements, and those basically we don't know the charge. When naming them, it becomes a little trickier than naming the main group elements, but that's not very important to know for Lewis structures, so you don't need to know too much on that. Anyway, as you have the 1A, 2A, 3A, going down, these are called groups. When you have 1A, 2A, 3A, 4A, those are your groups. Going across, 1, 2, 3, 4, 5, 6, 7, as you can see, going across here, those are your rows or periods. And that's, basics of the periodic table. So now I'm going to show how you would read an element that, is pulled out from the periodic table. So I decided to choose carbon. It's common, it's easy. So I pulled out, it's in the 4A group, as you can see. And carbon, basically when you read a symbol like this in the periodic table, carbon, that's the atomic symbol. So that's the symbol that we give carbon whenever we're, doing like, molecular, when we have to write the symbols out for them or anything like that, that's what we're going to use. Up here you see the number 6, and that represents the atomic number. The atomic number is the number of protons that are in the atom, and of course, as we all know, the number of protons is equal to the number of electrons. Down here we have the atomic mass, and the atomic mass basically is the average of all the atom's isotopes, and it's not very important to know for drawing Lewis structures, but for just general knowledge, an isotope is basically an atom that doesn't have the same number of protons and neutrons. There's a different number of neutrons. And carbon could have several different varies of isotopes. You could have carbon that has the same number of protons and neutrons, a carbon that has one more neutron than proton. So this is basically the average of all their isotopes. So this is the average. This is how many protons are in the atom, and then you have up here, this is the group number. Now this is very important when coming to drawing the Lewis structures because this lets us know how many valence electrons this carbon has. So you look at their group number to determine, up here you look at the group number to determine the number of valence electrons, so that's important. Other than that, I think I covered the most of the basics of knowing what you need to know for the periodic table in order to draw Lewis structures. So